So welding technique, what good looks like? Deck 5, gas tungsten arc welding stainless. We need to control the process. Gas tungsten arc welding is precision welding. And if we make small changes, things are going to happen. We can screw things up. And the whole process, well, this is welding in general, is we control the heat, we control the movement. We control the movement of the electrode. It allows us to deposit sound weld metal into the weld joint where we want. One of the things we need to keep track of is torch angle. A couple of different techniques, but the one we're going to talk about on this slide is we're just going to push it at a slight angle of 10 to 15 degrees. We don't want to drag the puddle, we're just going to push it. And we're going to keep the gas coverage over the weld. Otherwise, if we don't have gas coverage over the weld, we're going to get contaminated and we're going to have to end up cutting it out and redoing it. Arc length. We need to keep the arc length short and tight. If we have too long of an arc length, we're going to end up with contamination in our weld puddle. So on this one, consistency matters. People that are really good arc welders on other processes might not be such great TIG welders. But TIG welders to me are like surgeons, very exact, very tuned in, and very precise. So one of the things, like I said, arc length, we really need to keep that arc length short and tight. Travel speed, this really comes into play when we are welding things up that have heat input problems, or the material needs to have a specific amount of heat input. So you need to have put the right travel speed in so we don't put too much thermal energy into the material and then change the mechanical properties of the heat affected zone and or get weird stuff going on with the base material. So if we travel too slow, we're going to put too much heat into the material. If we go too fast, we're not going to get fusion. So if you are TIG welding, you're going to have to find a steady pace and go with that steady speed. Filler metal technique, we want to add filler metal slowly. Just a little dab here and there. We don't stab the puddle. We're just going to slide it in there. Keep the filler metal in the gas coverage, because if you pull it out, there's a chance you could get contamination, and you're putting all that contamination right back into the weld puddle the next time you dip in there. Heat control. Stainless steels hate excessive heat. We can get all kinds of weird things happening if we overheat the material. So we need to watch the amount of heat we're putting in it. We need to watch the puddle size, make sure we don't get some kind of ginormous puddle. And then we need to do this, how we're going to control our heat input. We're going to control it with our amperage and our speed. Sometimes we might have to travel faster and or turn down the amperage depending on what we got going on. So heat tint, what the heck are we talking about here? Well, when we're done with stainless, we've got this heat tint, and then there's colors associated with it. So if we get, light straw, that's going to be acceptable. And if we get blue or purple, that's too hot. Dark means our shielding is just garbage. So if we're done TIG welding, gas tungsten arc welding, and everything is dark and blackish, we have an issue. We don't have either any shielding gas or, I don't know, a couple other things could have gone wrong. So some common technique mistakes that we could see with gas tungsten arc welding. Well, if we long arc it, if we get our arc length too long, we can contaminate the weld puddle. Or we could overheat the weld. Maybe we just sit there and stir it and keep everything hot and just stir the puddle trying to get everything smoothed out and perfect or something. Or we stay in one spot for just a really long, absurd amount of time. We can overheat the weld. With Gas tungsten arc welding, especially with things like duplex stainless steels, we want to have, a lot of times we want to have minimal heat input into these materials, because if you have too much heat, it can do a lot of weird stuff to them in the material strength and, mechanical properties kind of way. And it can damage them metallurgically and corrosion resistance wise. So if you're dealing with stainless steels, overheating is really important that we don't do that. Poor filler metal control. Well, that's, you're dabbing things in there and gobbing it up and it just looks like rough. Losing gas coverage. If we lose gas coverage, that's going to be problematic. Maybe we're in a shop where there's, drafts and we're exposed to air movement that we probably shouldn't have. We're going to lose gas coverage, and then we're going to have some associated problems and discontinuities and defects associated with losing that gas coverage. So what does a good weld look like? Smooth, even bead, consistent width, minimal discoloration. This is a pretty nice looking weld there. That's what we're looking for. Well, not that every time, but you know what I'm saying. So bottom line, we need heat control, keep the arc tight, and we need to stay consistent when we're welding.